Okay, so this is our module outline, okay, for measurement and instrumentation. I hope this for you also, this may be a 1 credit, okay, maybe 2 credit, okay, we will check it later, okay. Uh, so anyway, this is our subject, okay, and we have three learning outcomes, okay. These are the three learning outcomes, okay, and uh, you will have some continuous assessment, okay. One is mid-semester exam, and you will have 2 or 3 assignment, okay, and one lab session also here planned, okay. I don't know whether you can participate or not, but I, I, I I wish you could participate it, okay. If you couldn't participate, we will not consider the lab marks for the final grade, okay, for the continuous assessment, okay. But mid-semester and 2 or 3 assignment, uh, uh, home take assignment will be evaluated for a continuous assessment. Okay? So that will give you 30% weightage to the final grade, okay, and you have to face the final end exam, okay. Most probably it will be open book exam, okay, it's still not decided, but most probably it will be a open book exam, and 70% will be given from final marks, okay. So this is for your final grade, okay. 30% from continuous assessment, that means mid-exam and 2 or 3 assignment, and 70 from the final exam, okay. So that is how your evaluation is done, okay. And these are the learning outcomes we have to follow, okay. So first learning outcome is describing the characteristic and operation principle of electronics measurement instrument. Okay. So under this learning outcome 1, we will learn basically uh, basically 5 types of measurement as I can remember. Okay. One is resistance, inductance, and capacitance, LRC. Normally we call them LRC, no? L for inductance, R for resistance, C for capacitor. Okay. So inductor, resistor, capacitor measuring, okay, or inductance, resistance, and capacitance measuring will be done. Okay. Then we will learn volt and current measuring. Okay. Volt and current measuring, voltage and current measuring. Then we will see signal measuring. Okay. So signal may be time domain signal or frequency domain signal. Okay. So these are the basic measurement we should follow. RLC measurement, that means inductance, capacitance, and resistance measurement, voltages and current measurement, then signal measurement. Okay. Signal will be time domain and frequency domain. Okay. So that those are covered in learning outcome 1. Okay. In learning outcome 2, we are mainly focusing on error analysis of the measuring instrument and readings. Okay. So that is belongs to learning outcome 2. So there are many characteristics we have to learn which relates to instrument. We will learn them, okay, later. Okay. Then in learning outcome 2, we have to design a simple measuring instrument. Okay. So most probably it will be an embedded uh, uh, system, okay, using a microcontroller or uh, embedded board, FPGA or Arduino, likewise board. We will do a simple measuring instrument. Okay, we will learn how to implement a simple measurement instrument. Okay, so these are the three learning outcomes we have, and you have the details things. Okay, later you can refer them. Okay. Uh, okay. Uh, if you have any problem, you can ask me. Okay. Uh, do you have any problem related with the evaluation and these learning outcomes? These are the approved learning outcomes given by the uh, head of the campus. Okay. Uh, so if you have any problem, you can ask me. Okay. Okay. So here you have your reference book. I have uploaded the reference book. Okay. So we are very strictly strict to the reference book. Okay. Because you can find every details within this reference book. You no need to go for other resources. Okay. So our study will be mainly focusing on this reference book. Okay. So I will show you the reference book. So you can get it. Okay. You can get it from this link. Okay. So here is my Google Drive a link. You can access it to, and you can download the book. Okay. Please take the book. Okay. That is very important. Okay. Uh, okay. Okay. Today we will, so I hope you don't have any problem. If you have, you can ask me related with the learning outcome and the evaluation procedure. Okay. So we will start to learn this learning outcome one. Okay. Describe the characteristic and operation principle of the measuring, electronics measuring instrument. Okay. So under this learning outcome, we are going to learn, as I told you, uh, LCR measurement, inductance, resistance, and capacitor measurement, as well as voltage and current measurement and signal measurement or signal observation. Okay. So I think that is the preferred word, signal observation. Okay. Time domain and mainly frequency domain signal. Okay. Okay. So we will start our discussion with LCR measurement, uh, inductance, capacitance, and resistance measurement. For that one, so there are many methods to measure those uh, those parameter or those item, those component. Okay, there are many standard measurement techniques. Okay, so one popular technique is using these bridges, AC and DC bridge. Okay, so this bridge we normally use to measure inductance, capacitance, and resistance. Okay, and there are two type of bridge, as you can see. Okay, DC and AC bridge. Okay. So DC bridge means we are using a DC source here. AC bridge means for this circuit, for the AC bridge circuit, we are using AC source. Okay. So maybe now we can understand that using DC bridge, we can only measure resistance. No, we can only measure resistance because capacitance and inductors, capacitors and inductors are not working properly with DC voltage. Capacitor act as a open circuit for the DC source at the steady state level. Okay, it capacitor act as a open circuit or open circuit or open loop at steady state for DC signals, DC current or voltage, and um, inductor act as a short circuit component, or it act as a short circuit at the steady state level for DC DC source. Okay, DC voltage and current. Okay, so basically DC bridge we can't use for measuring inductance and capacitance. Okay, so DC bridge we are normally used to measure resistance. Okay, okay, I will move to the reference book. Okay, I will move to the reference book. This is the reference book. You can download this in the LMS page. Okay, and so actually this bridge um, topics that sub this bridge are discussed in the chapter 11. Okay, not chapter 1. Okay, so our studies begin with the chapter 11. Okay, don't worry. Okay, our study will be beginning with chapter 11. Okay, so there the bridge related things are there. Okay, so as I told you, there are two type of bridge. DC. I'm sorry, I don't have the my writing pads. Okay, so I'm using mouse to write. Okay, on the screen. Okay, so this may be not clear for you, but don't worry. From next week, I will use my uh, um, tablets. Okay, then it will be fine. Okay, so basically there are two types of bridge: DC bridge and AC bridge. Okay, so as I told you, bridge are used to measure inductance, capacitance, and resistance, LRC measurement. Okay, LCR measurement. We use bridge. Okay, so there are two type of bridge, DC and AC bridge. Actually, DC means it use a DC source. This is related with the source. Okay, the voltage source, DC voltage source. That means a battery. Okay, here we are using a battery, simple battery to power up the circuit. Here we are using AC source. Okay, here we are using AC source. Alternative voltage to give the power to the circuit. Okay, so DC bridge can be used to measure only resistance, but AC bridge, which use AC source, AC voltage source, can be used to measure inductance, capacitance, as well as resistance. Okay, so AC bridge is mainly used for measuring inductance and capacitance, but resistance also can be used through the AC bridge. But DC bridge we can only use, the DC bridge can be used only to measure resistance. Okay, because as I told you, at the steady state level, steady state level, capacitor act as circuit, open circuit. Okay, but at the steady state level, inductor act as a short circuit, short circuit. Okay, so this steady state happen when the DC source is given. So DC source you can't use to measure L and C. Okay, so these are the main type of bridge, DC and AC. Okay, so we will first focusing on DC bridge. So that is not much difficult. Actually, I hope you have already learned this stuff. Okay, So I'm not going to much focusing on this. Okay. So if you have any problem, you can ask. Okay. Mm, okay. So this is a DC bridge. Okay. This kind of arrangement structure. This is the normal bridge structure. Okay. Or the arrangement. Okay. So this is called Winston bridge. I hope you have learned this for A level. Maybe you can't remember if you are not in that field. Okay. Uh, but you have already learned these things, I hope. Okay. So it will be easy for you. Okay. So this is a Winston bridge. Okay. So this is a DC bridge actually. This is a type of DC bridge because here we are using a DC source. Okay. So we have four resistance. Okay. Four resistance connected as a bridge, and there's a galvanometer connected between C and D. Okay. So this is the arrangement of the Winston bridge. Okay. So operation is also very simple. Okay. So maybe you can write this. So you can see that when the source, this is a DC source, that is why it is called DC bridge. Okay. So once this kind of voltage source is there, okay, so it will create some no, voltages here. Let's say that here voltage is VA, this voltage is VC, this voltage is VB, and this voltage is VD. Okay. And also some currents are flowing. I1, I2, I3, I4. Okay. Now tell me, mm, so basically to analyze this circuit, we can apply Kirchhoff law. Kirchhoff law. There are two types of Kirchhoff law. Can you remember two Kirchhoff law? Can you remember what are the two Kirchhoff laws? What are the two Kirchhoff laws?
The current coming into a bridge equals to the current going out.
Yes, that is one Kirchhoff law. Very good. Okay.
Yeah.
That is good to keep in remember. Okay. Because maybe now you are away from the subject now. Okay, so that is
Yes.
one, yeah, that is one law. That is we call Kirchhoff current law. Can you remember? KCL, Kirchhoff current law. So that
Yeah.
means if you have any point, the algebraic sum of the current of this point is equal to zero. In other way, all the current to the point is equal to the current out of the point. No, this
Yes.
input and output currents are equal. That is Kirchhoff current law. Then other is the Kirchhoff voltage law. No, Kirchhoff
Yes.
voltage law means if you consider a loop, okay, the algebraic sum of the voltages are equal to zero. Algebraic sum, okay, of the voltages will be zero. Okay, so that is Kirchhoff current law and Kirchhoff voltage law. And sometimes we have to apply Ohm's law, that is V equal IR. Okay, for resistance, we can apply Ohm's law, V equal IR. Okay. So it is good to have these things remember. Okay. Uh, so anyway, so now you can see that if you consider this circuit, okay. Uh, okay. So I will ask one question, okay, related with the Kirchhoff current law. Okay. So if you consider this C point, okay, the I1 is coming here, I1 is coming here, and I3 is going there. Okay. And sometimes some current may be going through the galvanometer also. This is a voltmeter. This is a voltmeter. no? So according to the Kirchhoff law, I1 is equal to Ix plus I3, no? According to Kirchhoff law, I1 is the incoming current to the point C, and output current, out current from the point C is IC and I3 and Ix. I3 and Ix. What can you say about this I1 and I3? What can you say about this I1 and I3? This is a voltmeter, no? This is a voltmeter. So voltmeter normally considered to have the high resistance. Voltmeter
Yes.
normally considered to have high resistance. Okay. So if it has a high resistance, that means this current will be very small. Okay.
Small.
So normally we assume that the current through a galvanometer is equal to 0. No?
Yeah.
Maybe you can remember. Okay. So basically this Ix can be considered as 0. Okay. Then normally I1 is equal to I3. Okay. I1 is equal to I3. In the same manner, I2 is equal to I4. Okay. Now, if you apply the Ohm's law, okay, so you can apply the Ohm's law to this branch and this branch and this branch and this branch. No? Can you write that equation? If you have a pen and paper, just write the Ohm's law to AC terminal, CB terminal, and AD terminal, and DB terminal. So if you consider AC terminal, okay, so battery is, this is the plus value, okay, this is the minus value. So current is going through this path, no, from here to here, okay. So this will be a high voltage point, and this will be low voltage point because the current is flowing from A to B, A to C. So if you apply the Kirchhoff law, Ohm's law to AC terminal, it will be VA minus VC equal I1 R1, no? I1 R1. This is one equation, okay? In the same manner, you can put the Ohm's law between this one. So it will be VA minus VD. This is VA, okay? VA minus VD is equal to I2 R2, I2 R2, I2 R2. Okay. Then VC minus VB, VC minus VC, VC minus VB, VC minus VB is equal to I3 R3, I3 R3, I3 R3, and VD minus VB, VD minus VB. This is B, okay? This is B. VC minus VB is equal to I3 R3. VD minus VB is equal to I4 R4. I4 R4. This is the Kirchhoff law. No? This is the, we are applying the Ohm's law. This is the Ohm's law. And we have 4 equations. Okay. Okay. Now let's consider this one resistor is variable. This one resistor is varying. Okay. As we wish. Okay. අපිට ඕන විදිහට මේ R3 change කරන්න පුළුවන්. Okay, we can change this R to any resistance. Okay, any resistance as we wish. Okay, so let's imagine this R2 is a variable resistor. Now, when you are changing this resistor, what happened? This current and voltages are changing, no? Because when you are changing the resistance, the total resistance of the circuit will be changed. So the total current also will be changed because the battery value is constant. That means all path current will be changed. Current will be changed means voltage also will be changed. Okay. So basically what you have to understand is when we are changing one resistance, if you consider one resistance as a variable resistor, and once it changing, these voltage values and currents value will be changed. Okay. So at any point, sometime, so those voltages are changing means the reading of the galvanometer is also changing. No? The reading of the galvanometer is VC minus VD. This is the reading of the galvanometer. The voltage between VC and VD. The voltage difference between this C and D terminal. It measures this galvanometer, no? Voltage difference between C and D measured by the galvanometer. So VC and VD will be changed when you are changing the resistance. Okay. So so that means this galvanometer reading also change, no? When VC is VC and VD is changing, this VC and VD is changing galvanometer. Readings also will be changed. Okay. So sometime this galvanometer reading can be zero. This galvanometer reading can be zero. That means what? It can come to zero. That means what? At that time, this VC is equal to VD. Yes. This one and this one equal, no? Okay. So at that time, galvanometer will be zero. Okay. Actually, that's condition we called as balance condition. We called it balance condition. Okay. Balance condition. We called it balance condition. Okay. So actually, don't worry. Very easy concept we have to learn through this subject. Okay. Not much difficult things. Okay. All things are like this actually. Okay. Not much difficult. Okay. So you can easily pass this exam. Okay. So don't worry. Okay. So this condition we call balance condition. Balance condition means what? The condition or status when this galvanometer reader is reading is zero. Okay. So at that time VC and VD is equal to zero. Okay. So if you connect the galvanometer with this terminal, what happens? To AB terminal, what happens? What kind of observation can you expect? If you connect the galvanometer within AB terminal, what happens? Just see what happened. What happened? A and B is connected to the battery, no? Source. Okay. So when you are changing this resistor value, this voltage source will not be changed. That give a constant value. Okay. So this AB terminal is connected to the battery, no? So this between this AB terminal, VA minus VB will give you the battery voltage, no? VA minus VB will give you the battery voltage. Okay. Because battery is connected to that terminal. So VA minus VB, VA VA minus VB what? That is battery voltage, actually E. Yes, it is C. Okay. So that means if you are changing this resistor, this E will not change. That means if you connect the galvanometer to the AB terminal, when you are changing the resistance, that reading will not change. It will give you the battery voltage, no? So that is not changing. So definitely you have to fix the galvanometer to the other terminal, not the battery connected terminal to the other terminal. So battery terminal can be connected here to CD terminal. If so, you have to connect the galvanometer to AB terminal, not the battery terminal. Okay. So balance condition you can get if you connect the galvanometer between the other terminals, not the battery connected terminals. Okay. Okay. So this is we call the balance condition. And can you try to get the relationship between this resistance and the balance condition? Actually, you should be able to get this kind of uh, what is called the relationship. Okay, so that is very easy actually. Okay, we have this equation. Okay, so already you know that I1 is equal to I3. I1 is equal to I3. So you can put this one I3. Okay, I1 is I3 and I2 is equal to I4. So you can put this one as I4. Okay. Then if at the balance condition, that means this VC and VD also equal. VC and VD also equal. So you can write here instead of VC, instead of VC, you can write it here VD, no? VC, because VD is equal to VC. Okay. Here also, instead of this C, or instead of this D, you can write VC, because VC and VD are equal. Okay, then what happened? VA, VC. So I1, I3, R1 is equal to I4, R2. No? So you can write using this equation and this equation. You can write I3, R3, I3, R3, I3, R3 is equal to I4, R4, I4, R4. Okay. In the same manner, using this using these two equation, VC, VB, here also VC, VB. You can write I3, R3, I4, sorry, I3, R1, no? First, we have to consider this one. I3, R1, I3, R1. Okay, I will put it as like this, okay? So this one, if you consider this one, I3, R3 is equal to I4, R4. Then if you consider this one, that means VA, VC, VA, VC, that means I3, R1, I4, R2. Okay, I3, R1 is equal to I4, R2. Then what you have to do? If this is A and if this is B, you can get A divided by B. Then I3 cancel out, I4 cancel out. You will have R3, R3, R1 is equal to R4, R2, R4, R2. You can get this relation easily for the balance condition. Okay. You can write this as, okay, so you can change the up and down. So you can write this as R1, R3 is equal to R4, sorry, R2, R4. Okay. So this is the final one you have to get. Okay. So you no need to derive this. Okay. But you have to remember this relation. Okay. So easily you can remember this is the galvanometer. And if you consider one side between galvanometer R1 divided by R3, that is, this one is equal to R2 divided by R4. That means this one. Okay. So if you consider the galvanometer, this side is equal to this one divided by this one is equal to this one divided by this one. So in that way you can remember it. Okay. So this is the relation. Okay. Then if you know, so there are four resistance. If you know any three resistance and another is unknown resistance, you can easily find the resistance. No. Okay. So here R4 is considered as unknown resistance, sorry, okay. And this R2, R3, R1 are known resistance, okay. So here R4 is subjected, okay. So R4 is equal to R3, R2, R1, R3, R2, R1, then, okay. So this is the relationship. So you can get easily, okay. So here one example is given, okay. R1, R2, R3 is given, okay, at the balance condition. These values are at the balance condition. So you are asked to find the Rx value, okay. So maybe you can find that using this relation, okay. So Rx is considered as R4, no, unknown resistance, okay. The sensitivity we will talk later, okay, when we are studying the LO2, we will comes to the sensitivity, okay. This time no need, okay. So here the unbalanced Winston bridge is there. Unbalanced means this AB, the voltage between AB not equal, okay. So at that condition is the unbalanced condition. If this voltage are same, VA and VB are same, that means no voltage different between these two terminals. It is considered as balanced condition. Okay. So if it is not unbalanced, if it is not balanced, here they have all again calculate the currents and the voltages. Okay. Here they are using the Thevenin equivalent circuits. Okay. So maybe try to understand this by yourself. Okay. Actually, one questions come to the exam paper related with this one. Okay. Uh, so maybe you have already forgotten these techniques. Okay, Thevenin equivalent techniques, those things. Okay. Anyway, try to remember. Try to do this one. Okay. Uh, and there are some slightly unbalanced bridge, okay, so that error will be generated, okay. So we will talk this when we are discussing the errors in instrument, okay, not this point, okay. So maybe you can check this one also. These are very easy to understand, maybe you can check, okay. Okay, here again, this is with this one is with the error, okay. So we will see them later, okay. So some applications are given related with the Winston bridge. Actually, Winston bridge cannot use to measure low resistance value because these resistance are connected with the terminals now. For the low resistance value, this terminal resistance also will be significant. Okay. So because you have to consider when you are finding very low resistance, this wire also will have some resistance. Okay. So it will impact to the low resistance value. Okay. If the big resistance value, this impact can be negligible. Okay. So it is not introduce any error or very less error. Okay. But if you are measuring low resistance, it is somewhat difficult. It is somewhat not good. It is not good for measure the low resistance. It is not preferred. Okay. And there is another bridge, another DC bridge that is we call Kelvin bridge. That is also the modified form of a more improved version of the Winston bridge. Okay. Uh, mm, so maybe okay. So anyway, we will stop here. Okay. We will next week. I will check whether your subject is 1 credit or 2 credit. If it is 1 credit, no need to focus in on this Kelvin bridge. Okay. Then we can go to the AC bridge. Okay, AC bridge. But if it is 2 credit, we have to learn this Kelvin bridge also. So first I will verify this, whether you have 1 credit or 2 credit. Are you power systems students or telecom students?
I'm power system students.
Power. Okay, I will check with Dr. Nikolai. Maybe for you it will be 2 credit. Okay. Then we have to
Okay.
learn this one also. Okay. Then I will check it first. Okay. Then we will continue. Okay.
Okay, sir.
Okay. So if you have any problem, you can ask. හරි මොනවා හරි තියනවා නම් අහන්න.
Mm.